So today we have this international expert from University of Chittagong, Bangladesh. He will be taking a session on disaster management and resilient sustainable cities in South Asia. And Dr. Biswanath is a professor in the Department of Geography and Environmental Studies, University of Chittagong, Chittagong, Bangladesh. And he received his PhD degree under CAS TWAS President's International Fellowship Initiative in 2015 in Cartography and Geography Information Systems from the Institute of Remote Sensing and Digital Earth, REDI, former Aerospace Information Research Institute, University of Chinese Academy of Sciences, Beijing in China in 2019. He joined as a professor in the Department of Geography and Environmental Studies, University of Chittagong, Bangladesh in 23 and currently holds his position. Earlier, Dr. Nath served at the same department from uh, 2011 to 2013 as a lecturer. Yes. Assistant professor from 2013 to 2019, associate professor from 2019 to 2023. In addition, before starting his teaching career, he worked professionally for several GIS organizations in India and Bangladesh from 2007 to 11. His present research interest focuses on applied remote sensing and GIS, early forecasting of multiple geohazards, and their associated change study, geophysical, atmospheric, and meteorological coupling, landscape risk mapping, geostatistical and digital photogrammetry applications, and drone applications. So, uh, So Dr. Nath is currently a visiting scientist at the Aerospace Information Research Institute, Chinese Academy of Sciences, Olympic Campus, Beijing, where I had been in 2008. So in 2023, he also visited the same institute for 1 month. In the past, he received a Berkner Fellowship grant for 3 years from 21 to 23 as an early career scientist from the American Geophysical Union, USA, to participate in the scientific conferences, workshops. Dr. Nath has published 44 research papers and 3 book chapters in internationally reputed peer-reviewed journals and books, and voluntarily served as an invited reviewer for several prestigious journals. He joined recently as an editorial board member of the journal Discover Geoscience by Springer. He oversees the undergraduate lab of remote sensing and photogrammetry and the postgraduate lab of geoinformatics and earth observation research. So you can see what what presentation we are going to have. We have discussed it, and I believe we'll be having a great knowledge experience, information experience now. I close my this thing sharing, and I welcome you, sir. Thank you very much for taking out your time from the busy schedule, and it is ultra busy. It is too busy, I know, and I just stopped sharing. And sir, most welcome. We welcome you here with us at MANIT Maulana Azad National Institute of Technology, and on behalf of MANIT and on behalf of ATAL Academy, on behalf of AICTE, I hope you must be knowing AICTE, ATAL, and I hope by now you must have definitely known. So we all welcome you on behalf of participants, and please share your presentation. Thank you, sir.
Okay, madam. Thank you. Thank you very much for your
Welcome, sir.
introductory regarding my progress. I welcome basically the introduce my gratitude to Pawan Kumar sir for referring me in your university, especially to you regarding this ATAL program. I'm very much lucky to have a present my research paper recently published and the past research focusing on the different landscape risk modeling and the earthquake, I mean the natural hazards monitoring in a hilly terrain, especially in China and Bangladesh, and focusing in this lecture. So I am very much helpful to to show my research to you, the audience was there. I hope they will learn something. And I've been trying always to have a to using the Earth observation satellite data
प्लीज अपना
in the
कैमरा ऑन
research
करो, मैं
fraternity to
कोशिश कर
show
रही थी
something
लेकिन
new.
आपका ना अच्छा नहीं लगा.
So please, I am sharing my slides. Please
Just
allow.
one second, sir. Just one second.
Yes.
This is like I'm coordinator of the course, and Rajat Soni, he is also associate professor Manit. He is co-coordinator. So, yeah, I hope you can see
Yes.
Biswajit sir and Pawan
Hello.
sir.
Hello, sir.
So,
Hello. Nice to
Hello,
meet you,
hello.
sir.
Yeah, same
It was
here.
a very namaskar, sir.
It's
It was a great time to have a meet you all. From
yeah, yeah. It's a
I'm
great
currently in
coincidence.
Beijing.
Yeah, but it's a great
Uh,
coincidence. I had been to your university in 2019.
in 19
Architecture
was
department.
in 2018 I returned back after my PhD.
See.
And it was awarded. My PhD was awarded in 6th January, and the last year I visited for 1 month, and then still is going on as a Pi 5 category, visiting
Right,
scientist
right.
category for the international collaboration research project.
Great, great, great.
Basically,
Please,
we are
it's
utilizing the Chinese government satellite data as well as the Landsat, the USGS satellite, the comparative analysis of to assess the critical area in Bangladesh by using the Earth observation data to assess the different kinds of disasters uh, with these satellite data sets.
yes,
Anyway, I will.
why don't you join Manmeet and Sandeep and Purnima?
I want to share my slides.
Okay,
Yes,
so
ma'am.
now कैमरा एक सेकंड कर लेते हैं, आप लोग तब नहीं दिखे थे मुझे.
Madam, I cannot. It's a little bit problem to share the slides.
But this is our team, and now I will put off all cameras. This is our team with the students and all.
Yeah, yes.
So now I hope you are in the. हम लोग अब कैमरा ऑफ कर देते हैं, and sir will share the now, sir. Thank you so much, sir. Now you can try to share.
Yes, madam. I'm trying to share, but the win.
On Teams screen, you can see the share button at the top.
Yes,
If you
I'm
can,
clicking that,
but
but it is.
yes, but before that, you have to keep your presentation open.
Yes, please. Is it visible, madam?
Right now, it is not visible. You have to go to share again and share screen.
Okay, okay.
I think yes, it has come. Now you can
it
make
is
it full
visible now.
screen.
It is visible.
It is visible.
Yeah.
Yes,
Yes, sir.
Yes, thank you.
you can make it full screen.
Yes, I'm trying, but uh, it would be good, madam, if you can continue with this with your
Yeah, yeah.
part.
Please continue. Please continue with this.
Okay,
Yes.
okay. If you are sharing, or should I share?
Yes, you can share also.
Okay, okay. Thank you so much. I'll
Yes,
share.
a little bit problem over there.
Yes, okay.
So I'm stop sharing right now.
Yes, yes. Okay.
Yes, yes.
I hope everybody can see the screen, the first slide.
Yes,
Yes.
Yes,
yes.
ma'am.
Yes, yes,
Yes,
ma'am.
ma'am.
Yes,
Yes, ma'am.
yes.
If you have any trouble viewing, or if I will request Biswajit sir to
Yes.
just convey some in between slides, that this is the next slide, this is the next slide.
Yes, yes.
So otherwise
Sure,
sometimes we miss shifting, like
sure,
it's on
madam.
the same one and we cannot see. You can start, sir. I
Sure.
will request participants that today we are definitely going till 9:15, 9:20. If Vispreet sir has a few more minutes, then we
Yes,
participants, and we don't mind extending our time till 9:20.
yes.
Okay, sir,
Think,
start,
please,
please.
please, please.
Yes.
Uh, Go to the second place, second page. Uh, I'm directly going through my lectures regarding the understanding the natural hazards and the resilience the with the two techniques a different area that we chooses for different analysis of the landscape risk, as well as the land use land cover change modeling, how it linked with the natural disaster, and how we assess the particular area that is undergoing stress. So by the naked eye, the people doesn't have any idea about how it is the area is changed through the courses of time. So first of all, to understand the resilience and the things the natural hazards, we have to go through the worldwide scenario first. The US scenario that is basically highlighted the United States experience over the $20 billion disaster in 2003. The cost are just not of the many problems that face a community affected by wildfires, severe storms, droughts, and other serious disaster incidents, which is still ongoing in the USA. The importance of interdisciplinary team of experts is necessary to tackle this kind of disaster in advance. By knowing the problems in advance may reduce the risk of the particular disaster event. The outputs and the formulation of international joint collaboration networks will directly support the decision makers in developing actionable plans, improving policies for disaster management and resilience. But what happened in the next place? But we have to understand the scenario of the in Asian context. Second slide, please. Yeah, if you
The
look
next one, or the
about the South Asia's perspective, you can see the South Asian countries,
okay,
especially the
okay,
India,
okay.
China, Nepal,
Yeah.
Bangladesh,
This one,
Pakistan, Sri Lanka, Bhutan. Yes, uh, Sri Lanka, Bhutan, and Myanmar also faces larger disaster more frequently. Understanding the involved mechanism deeply will helpful to tackle the particular disaster. There are multiple disasters such as earthquake, flood, regular and flash flood, including under this flooding event, landslide and the ground subsidence, riverbank erosion, and the groundwater depletion are observed in these countries. And in recent time, multiple disasters are occurring frequently. This makes a problem for the urban and semi-urban areas, people residing in the mountainous and hilly towns of the respective country. Basically, people in these areas are living in risk-prone areas without knowing the ground knowledge, or sometimes forcibly resettle in the particular terrain by following the government decision as the urban expansion or renewal program. This risk, the risk is more if the terrain is more prone to multiple disaster. Therefore, the knowing the matter early with the aid of geoscientific approach may reduce the disaster impact. Understanding geological fact, including the seismic activity, frequency of particular disaster, and the geophysical and surface and subsurface parameters, change monitoring using the multi-sensors Earth observation data are necessary. Therefore, the best way to prepare to respond to, recover from, and mitigate the effects of disaster will become increasingly important for the above mentioned country. Next slide, please. Next, please. Yes. In this lecture, the part one and part two will discuss about the landscape risk analysis of the 2003 Borkol Rangamati 5.7 magnitude earthquake in Bangladesh using geospatial techniques and people's perception. And the second part focuses on the landscape and land use land cover change modeling and future potential landscape risk assessment using Markov-Chia model and analytical hierarchy process. Next. Next, please. Part one. Next, please.
I hope this slide is okay, is visible now. It takes some time, I think. Disaster activity monitoring. Is this the slide you
Yes, the
want?
part one is right now I am focusing on.
Okay, okay. So should I change? Next slide?
Yes.
Okay. The part one slide has come.
Yes, but the next slide, please.
The part one landscape risk analysis of 2003. This slide I have changed already. Is it visible?
Yes, right now it's visible.
Okay.
Okay, landscape risk basically in this research we have to focus on the understanding the land use and land cover change, variability, and landscape risk assessment in the earthquake prone areas. Basically, this paper is published on 7th January, just 2 days ago. So I'm focusing on these important research. This paper considered Borkol town and its environment in the earthquake-prone region that was affected by the 2003, with a 5.7 magnitude in the Rangamati Hill districts, Bangladesh. For the LR changes, I mean the landscape risk, we have considered the data sets of the Landsat satellite series of 2001 to 2024. The 6 multi-temporal data sets of the uses for 2001, especially 2003 and 2011, 2021 and 2024 are used for the detailed analysis to assess the spatial and the temporal land use land cover and the LR changes. Basically, these 6 different multi-temporal are considered to know the systematic changes of the land use land cover, how it impacted, and how the landscape risk have developed during the time courses. Especially, we have a focus on what happened before the earthquake, during earthquake, and after the event is over, and what are the risk factor, what are the status of the current level in immediate before this year, I mean the 2024. So that is basically we have to focus on, and the research is going on by considering with the multi-temporal data sets as well as integration techniques of the GIS and remote sensing. So brief introduction, basically we are focusing on this area, Rangamati, that is basically closely bordered with the Indian Mizoram, and the Baghaisari and Langadu Upazila, and Juraisari Upazila in the south. And on the east, there is a Mizoram border. Langadu and the Rangamati Shodor Upazila are located on the west. So you can see the complex nature of the the location of the Borkol area. So that is very complex terrain area. Multiple fault lines are crossing over there. So earthquakes are occurring frequently within this area with a certain time interval. This region is basically located in active tectonics due to the collision of the Indo-Myanmar East-West plate convergence. In the study area, we have observed the first earthquake on 1st January 1969 with a magnitude of 5.4 and 5.7 magnitude with the several cluster aftershocks with 4.5 to 5.5 magnitude in nearby during the 26 July 2003 earthquake up to 1st August. So it's a continuation of the main event and the aftershocks event for the few couple of weeks. So you can see there is a multiple fault lines as well as is the green dot representing the different and the multiple colored dot with representing the different kinds of magnitudes of the earthquake that is impacted in this locality. Next slide, please. These are the Landsat data sets that we considered for the Landsat 5, 7, TM, and Landsat 8 OLI. For the different time interval data that we considered for this analysis, the resolution you have already know that this is a 30-meter resolution data, and this path and row was considered for the analysis. So in between 2003 we have considered two images because earthquake happened in this particular area with the in the mid of July. So the January and the November was considered for the pre and post event analysis as well as the recent, and the before we are considering the 2001, and the recent and very recent considered as the last 30th January 2024. Next slide. Next slide. The following methodology that we considered for the this particular research, especially the ALR mapping was particularly done with the help of GIS and multi-criteria evaluation techniques with the analytical hierarchy processes that is widely scientifically widely accepted. But in this research we have apply the validation method with the landscape risk with the output of the landscape risk with the lineament density that we extracted from the Landsat satellite imageries, which is a new technique that I have introduced in this research the first time for this in the research fraternity. The ALR mapping of the study region was prepared using various tools and approaches of geospatial techniques, lineament density, local geology, ALR analysis, and with the various land use land cover of the different timelines. The ROC AUC curve was considered to validate the LD image with the LR with the generating of the multiple points to validate the the risk mapping. You can see the overview of the different types of multi-temporal data, how the research is progressed with the different methods. Well, first we have a analysis of the unsupervised classification of the land use land cover. Then these factors of the lineaments data was extracted with the line algorithm of the GPCI Geomatica of the particular time frame. Especially we have a different time because we are not considering the specific 1 or 2 time data because we have to know the status of the changing nature of the area, how these earthquake happened was there, and what the risk factor was there before earthquake struck. Is there any previous earthquake occurred in that area in the past, and what are the status of the recent times? So that is the way we are targeting the area to investigate with the research gap after a long gap because there is no research concrete research findings regarding this earthquake. Only the one paper is available regarding, but we have introduced the new techniques and methods to have how we can assess the present risk and by knowing the earlier and the past event. So there is a geophysical data set, so like the dam geology, fault lines, earthquake data points are considered for the different these ASP modeling purposes, along with the lineament density data of the particular time frame were considered, and the lineament density also considered finally for the ASP modeling. Rose diagram was prepared for the directional change monitoring. I mean, how the event was occurred and how the area was stressed and which direction it is moving. So you have to figure out these changes with the Rose diagram, and then we have to perform the weighted overlay techniques for the analytical hierarchy process applied for the with the ArcGIS raster calculator for the, and we prepared the landscape risk map for the certain time frame. And finally, we validate our model and overall our understanding of the risk text with the quantitative analysis. Next, please. This is the results that you have derived based on the different 6 sets of Landsat data. You can see the extent of light and dense forest varies in spatial distribution over the years. This is the first image is the 2001, then 2003, the January, and then November. In between, we have a place the multiple earthquakes events. You can see the stress, how the stress have transferred, and how these earthquakes have happened in this particular area of interest within the short period of time. And all the earthquakes happened in this kind of aligned to this close to the fault lines. So mainly the forest changes from dense to light were visible throughout the area, as the land use land cover data sets have clearly distinct. Barren and increased land significantly after 2000 Bhopal earthquakes, and the amount of 115.60 square kilometer was the highest value observed in 2011. During 1 and 2024, barren land was below 100 square kilometer. It maintained 11.30 square kilometer and 75.50 square kilometer respectively. Land use land cover, we have identified that there is the main driver of the changes in this area. The change is positive due to the widespread use of the settlements with the vegetation. As the population of the Bhopal area also tremendously increasing day by day, the number of settlements grew significantly in the study area. After all, the Bhopal earthquakes in 2003 up to 2011, the total settlement area in this area was observed approximately 107.60 square kilometer. However, in recent past, in 2001 and very recent time, settlement uses were 180.56 square kilometer to increase into 185 to 2.5 to 25 square kilometer. However, this in 2001 it was only 36.31 square kilometer. So you can easily understand how the population have tremendously increasing this area by their own initiative. They have altered the landscape. So they doesn't have any sense of the ground knowledge or how they impacted the grounds along the fault lines and other things. The peoples are resettle people developing their settlements to have a living over their specific risk area, but they don't know how this area have changed over the courses of time. Next slide, please. For the research progress, we have to focus on the lineament data. That is very vital and very important part of our research, along with the land use land cover. In this present study, we considered the freely available data, USGS Earth Explorer. For these data sets are considered, and for the two considered of the 2003, one for individual year for the tectonic lineament data extraction, that is basically done with the help of line algorithm techniques with the PCR Geomatica, and the values of the by default values that is presence in the line algorithm. It was applied in this in a broad level context if you have considered the Landsat whole Landsat satellite scene. But if you can analyze a micro level part, so you have to focus on the modified parameters of the line algorithms. So these data you have tested I am testing in during my PhD, that when the larger area you have considered for the Landsat data, you can consider the by default parameters that is available, but with the modified value we have considered for the micro level landscape risk analysis. So that is the way we have to we have to understand the how these lineaments have changes through the courses of time. Next slide, please, madam. These are the important data that we have extracted based on the different time frame. There is the total lineament length, maximum, minimum, medium. This is the statistical information that we generated. You can see the number of lineaments was in 2001 before the earthquake. There was 1025. After the refinement of the lineaments by cleaning of all the artifacts removal, then we have find this kind of data. And important, immediate before the earthquake event, there is a lineament increasing tendency was observed. There is the number of lineaments was 1,204, and immediate after the earthquake event, you can see the drop of the lineaments. That is the natural division of the lineaments with the structural disturbances clearly observed during this earthquake event that is affected by this 5.7 magnitude earthquake with the aftershocks. Then how this area have damaged, that we can clearly see. And after the event is over, you can see the after earthquake 2011, and the lineaments frequency is also increasing, 1127, and then in recent time, in 2021, we observed that 1178. Gradually, it increasing, and in very recent, in the last year January, the satellite data and informed us that is the lineament is gradually more increasing in 1286 in number. So you can easily observe that the gradually increasing of the lineaments have put this tremendous pressure of of this area, and we easily understand that how the stress have been transformed again and again. So there is a more chances of the earthquake in the near future also. Next slide, please. Summary of the lineaments, if you focus on the specific area of interest, so that the prior to the ball call 2003, there was a total number of lineaments that we have already discussed. So we have also generated the lineament density based on these lineament data. So LD we considered as the lineament density, and a 9.66 kilometer per square kilometer high concentration, that is referring the high stress condition between different time frame, and the mean value was 1.29 kilometer per square kilometer. However, immediate before and immediate after the Borkal 2003 earthquake until 2011, changes in surface and subsurface stress have been observed to increase through the lineaments and the density change. The total number of lineaments that we have already discussed, that this is gradually increasing, and increasing lineaments was observed is also in the recent time also. The stress decreased slightly and reached to the maximum LD of 6.56 kilometer, and the average value was 1.18 kilometer per square kilometer. The SD value indicate the presence of stress anomalies which occurred prior to the 2003 earthquake and gradually decreased over the long period, but in recent time it is increasing. The study area observed the highest number of lineaments in very recent time, similar to the immediate before earthquake in 2000 January lineament scenario. These results indicate that the study area is not immune to seismic stress since it is ongoing, and we suspect that this region will be shocked by similar or higher intensity seismic events again. Next slide, please. The If you observe with the rose diagram, that is the directional change that gives us the very different directional level changes from the earlier time to before earthquake, during and after earthquake, and what is going on in recent time. So we have seen that there is considered as the prior to the 2003 earthquake event. This average strike line is shown with the red line, which is the mean value of this particular data. In the right side, the figures show a shift in orientation abruptly to a 12.3 degree north-northeast to 192.27 degrees south-southwest, a 6.2 degree forward rotating compared to 2001. So you can see that approximately 6 months prior to the main earthquake event, this was recorded. The main event occurred on 26 July 2003, and immediately after the event, the lineament direction further rotated back 8 degree north-northeast to 187.97, so say 4.3 backward rotating compared to 2003 January. However, during the 2011, it was observed to rotate the forward 1.8 degree compared to 2003 November. I mean the post-earthquake, with a mean strike direction 9.8 degree north-northeast to 189.78 degrees south-southwest. Next slide, please. And several low and moderate magnitude earthquakes in these rotating zones during 2003 to 11 was observed. But in recent time, the orientation further indicate north-northeast to south-southwest with more increasing lineaments and medium-high stresses observed along the mean strike line, direction of approximately in this 23.7 degree northeast to 13.9 degree. That is the 17.6 degree forward rotating from the year 2011 and 2001 respectively. At this time, the earthquakes of 4.7 in the southwest part and 4.4 magnitude earthquake occurred in the northern part of the near the upper edge of the Bhopal Upazila boundary. Moreover, the recent lineament data suggests the presence of higher stress developing in this area. The main strike line direction of approximately approximate cloud it means the highest stress developing in this area, and the mean strike line direction of approximately 16.2 degree north northeast to 7.5 degree and 3.9 degree backward and forward rotating from the year 2021. Very recently, we have observed that this also in swinging mode, and there is no changing or the constant surface was there. So there is some dynamic movement was observed in this rotational data. So this temporal directional data from the study area suggests that the presence of stress is ongoing and the dynamic movement is also ongoing. Next slide. And after extracting this data and observing the lineament direction and the landscape risk assessment and the mapping interpretation was done, the percentage of the influence is set according to the importance of layer mapping by considering the several important geophysical data that I have already discussed in the methodology section. So these earthquake points, fault lines, geology, land use, land cover of the particular time are considered for individual landscape risk assessment. I mean, the different temporal assessment landscape risk are produced based on the considering of the land use land cover and the lineament density data. That is each and every time we have considered, but the other parameters are fixed. Only these two variables are have changed because of the dynamic changes of this pattern in this time frame. So the different LR analysis of the study's results suggests that before, immediate, and immediate before and after, recent past and the very recent time, this area have how this area have changed. The landscape have changed in different direction, and where the high concentration, high level risk is developing before and after the earthquakes, and how it is going on in the recent time. That is clearly visible within this, and we have categorized it in 5 different categories as low, medium, high and very high risk categories. So the people of the living in this area have understand if they have their settlements are in the high risk or low risk or moderate risk. So we have a very clear understanding through these mapping exercises if you consider with the multi-temporal data of this modeling approach. Next slide, please. Immediate before earthquakes, the January 2000 line, there is higher level of risk of observed in the southwest and eastern regions of the study area. Prior to the 6 months, 5.7 magnitude earthquakes occurred. Immediately after the largely affected by the few aftershocks, which continued even the first week of August, we had a maximum magnitude of 5.5 and minimum of 4.1 magnitude were observed and all struck in the southeastern part of from the main earthquake event. The critical sites are mostly located in the medium to very high risk areas immediately after the earthquake. The ALR 2003 November data image shows a stress release condition where high and very high lineament and density based risk are representing that medium to low risk area in this area present. The ALR in 2001 shows significant changes in the level of landscape risk in this earthquake affected area, while low to high risk areas started to grow again within the vicinity of the 2003 main and aftershock events area. Several earthquakes occurred in this northern part of Bhopal Upazila, which has high and moderate landscape risk area. The maximum magnitude of the earthquake that struck during this time was 4.9 in the recent past. So that was basically in 1969, the first that earthquake struck in this area. So very recent period, This change observation, which represents the gradual increase of level of risk in the same areas, and no earthquakes are reported till date, but it will be occurred in the near future. So that's why this landscape risk assessment is important, and it is difficult to have to say when earthquake will occur, but we have to assess that it will be in very near to of different magnitudes like 6.5 or 5 point over 5.5, or previously it was affected by 5.7 or 6.5. We have estimated that it may have occurred based on the landscape risk analysis and the lineament concentration over the study area. Next slide. So we have also estimated the area, how much area have covered under the different sets of category. We have presented in the based on the different time domain. So various leaks level are marked with the different colors. You can see over here very low risk have a green color, similar to our mapping, our landscape risk map. So we have a graphically presented this area, the percentage of area that is, you can see the gradual increase of the risk factor, and also in the present time is also increasing similar to the earlier time. So LR in the 2000 was also reflected the medium risk, which shared 288.47 square kilometer, 30.8% share, and LR in the recent past observed 47.38 percentage, and 22.93% in this recent time. And in 2024 January, were 24.2.5 identified as the medium risk, and 15.28% identified as the high risk area. Next slide, please. Now, this important part of the research is how we, rely on this particular ASP model. So for that, we have to validate our model. So there is no way with collecting multiple points from the ground because of the larger area. So we have a different technique that we applied to collecting the lineament density, that basically typically representing the stress condition of the area as the time progresses with the Landsat data. We have continuously we have we can monitor with the Landsat 8, Landsat 9, and the earlier data that we have considered. So as the satellite have a progress with the Landsat 8 and Landsat 9, we have a frequent coverage of these areas globally. So we can easily assess this kind of area, or the area where this kind of risk are growing. So for that, we have to validate this model, and we have considered the 60 points, randomly points are generated based on the landscape risk map. This here I am showing for 2001 as for example. Similarly, I have considered the 60 number of points for the all landscape risk map based on the lineament density, and then we validate the data based on the ArcSGM with the ArcGIS environment to build this kind of our AOC and ROC curve to validate our model for the scientific approval. And the ROC AOC curve generated and performing well with the extracted values, 2 data sets. In our case, LD extracted point values of LR maps. The Monte Carlo simulation was adopted. 10,000 realization was done during each curve generation. The area under the ROC curve finds satisfactory test quality results. Varies between 0.604 to 0.67657, which is quite satisfactory to consider this modeling approach. Next slide, please. People's perception also we have investigated, because as it have a directly linked, the population have increasing in this study area, the earthquake affected area. People are living knowingly or unknowingly, but we have a very good number of representative samples that we have taken over the study area. The checklist survey was done, 20 checklist survey representing those who are people are faced this kind of earthquakes in during the time in the lifetime. So among the checklist, first 50% to 40% of the respondents reported that the 2003 Bhopal earthquake that occurred in their locality was an extremely high and high category, and only 10% said low intensity category earthquake observed, because the people have a different opinion, different feelings regarding the earthquake intensity. So they sometimes they feel, sometimes they are forget about everything. So after the long gaps, this kind of investigation we have performed, these responses were recorded those who stayed in this area at least 20 years from the survey time. All the respondents reported that they had observed this July 27, 2003 earthquake, stayed in various sites and places in the locality and neighboring areas, who are at home 75% or relative house 10%, and moved to another places or in nearby villages or union from their respective settlement. They are, during the earthquake, they are not staying their home. So in this response category, 80% respondents were male and 20% were in female categories. So you can see the earlier and the recent photo that we captured. Some are captured during when the earthquake was there, and after this is available through literatures, and D and ER we are collecting at the recent time, that you can see there is still the line of fractures in the buildings, and this is not yet recovered. Still, it was in vulnerable conditions. So these the Upuzilla Health Complex over there, and uh, different objects are. You can see that there is a mud-built house was there. So the roads are cracking during the earthquake time. So this is the rupture. We also measure the rupture events. For the time constraint, we are not representing over here. The surface and subsurface rupture events are also calculated through the specific formula. So readers are also I am suggesting to have a go through the full papers that I'm giving some in the end of the slides. The next slide, please. In If you closely observe this kind of event, what happened during or before earthquakes or after earthquakes, how the stress have changed in this area, which is not visible in the naked eyes. So, but the satellite have a very gives you the detailed clue about what is happening over the grounds. So you can easily check this status. So if we have a continuously monitored this kind of data, then we can easily estimate and we can easily understand what is going on in the upcoming time. So near field and far field stresses are changed assessed with the ground motions, observation of the study area, with the LD changes immediately before the earthquakes and after earthquakes. So within the near field observed with the 5 to 10 kilometer buffer distance is calculated, and close to occurred earthquakes with the main and aftershock events. Within this event, you can easily see the red dots of the main and aftershocks events within the close vicinity of the 5 to 10 kilometer buffer zone. The stress have been changed, and you can see the after the earthquakes, these have a stress have releases gradually. And in the far field stress, in the northern section of the area, that you can see the how the stress have lower compared to the main earthquake epicenter at the core buffer area of 5 to 10 kilometer. So 20 to 25 kilometer the buffer distance and the beyond are the far field have considered for our comparative analysis. Next slide, please. And if you go for the concluding remarks of this particular research, the present study utilizes geospatial integrated analysis technique, which provide information about the pronounced changes in the landscape risk associated with the earthquake struck in this area at a regular interval. So therefore, the lineaments and the LD changes over the study region are considered the most influential factors in identifying the ongoing changes. The study area is located in highly seismic prone areas in Bhopal, which is presently undergoing high level stress as revealed by the present landscape risk analysis. The people's perception results derived from this study also confirm the presence of risk factors in the study area. Furthermore, the special data with the techniques of analytical hierarchy process and multiple criteria analysis, the model suggests that the city planners and the local administrator to consider special temporal LR maps in their integrated sustainable and landscape planning. Right? These are our outcomes. The publications that is recently, the 2 days ago, it was published by the National Geomatics, Natural Hazards and Risks by Taylor Francis. You can see the journal have this published very recently. So these are the DY link. The readers are requested to have a go through. This is open access paper. So impact factor was 4.5, and it is indexed in SCI and Scopus. Uh, and next slide, please. We are going to the next level, part 2 presentation. Very quickly, we have to see the another cases of land use land cover, how the land use land cover and the futuristic modeling approach uh, in the earthquake prone area have helpful for this assessment of the landscape risk in this particular area with the Markov CA model and ASP techniques. This is quite similar to the right now I am concluding the first one, but have a different modeling approach for the futuristic approach. How it will be look like in the future, how it will be affected, or how the risk area have undergoing changes, so that we can assess with this kind of area. So for that study area, we have considered the 2008 Dujiangnan city that was affected by the Chinese earthquakes in greater than 7.8 magnitudes earthquake was there, and over 90,000 people were dead at that during that earthquakes. So you can imagine how big this earthquake event was there. So we have a very key intention. This research was done after my PhD defense to consider the study area to check the status of the landscape risk as the Chinese government have implemented a restructuring of the earthquake affected area, resettlement, and the people were more heavily developed their settlements in this area due to the urban renewal and other programs. So how it impacted and in the affected area, they again they're trying to resettle in the earthquake affected area. So in this particular research, we have to identify how the policy have been in wrong vein, so that we have to investigate. So we have to go through this research. The study evaluates the spatial temporal variation of future land use land cover changes with the landscape risk assessment of the 2008 grade 8 magnitudes in the UGS that reported, but in Chinese they had told that is a 7.8 like that. So that is a dilemma of the different magnitudes of the intensity. You can easily understand the risk factor over there. The cellular automata and Markov chain model multi-criteria analysis approach was adopted with the remote sensing and GIS techniques. Next slide, please. These are the basic understanding. We have to check the status of the sustainable development goals. This research is basically linked with that framework with the city sustainability assessment. And then the level 4 was the heavily impacted by the natural hazards like earthquake, floods, landslides, and forest fires. That was basically under this category. The term land use land cover change basically refers to human modifications and the terrestrial surface of the earth, as well as the study of the land surface change. The term transition defines the process of changing and the change of something from one form to another. Land use land cover at spatial-temporal scales in the metropolitan area has been carried out worldwide in earthquake-affected cities, watersheds area, coastal area, wildlife sanctuary areas using multi-temporal remote sensing data. But this is the first time we have introduced these techniques for this earthquake-affected region. And this paper is currently cited by 150. And moreover, we have considered the land use land cover model to be found effective when the predicting of the future state and the spatial distribution of the land use land cover using the gain knowledge from the previous years. Next slide. A group of scientists are working in the detailed analysis of the damages and numerous parameters associated with the deadly 2008 Wenchuan earthquake. The Chinese, it was reported as 7.9, but USGS have reported 8 magnitude earthquakes. This is located in the southwest of China. Numerous methods such as mathematical equation, spatial temporal modeling, system dynamic modeling, statistical cellular and hybrid models, cellular agent-based model were adapted in the literature. The cellular automata Markov chain model have been utilized in different researches. Next slide, please. In Sichuan province, many of the earthquakes are happen, and monitoring the degradation studies in the earthquake event area. Dujiangnan city was considered for this particular research. It was considered also as and well known as Asia's water tower, suffers from the frequent geological disaster. In the past, DCN, we refer these as Dujian city and environments in the research. We studied in detail by observing the area in 2018. Studied major landscape changes in the area where we have a fast research focusing on the changes of the ongoing based on the different Landsat data sets. But based on the earlier and last 2018 data, we have modeled using these techniques, and we have progressed with the futuristic approach with the 2025, 2030, and 2040 were considered with this automated and Markov chain modeling approach and the multi-carrier analytical hierarchy process integration. These research basically have suggesting you the sustainability indicator, whether this sustainable area is sustainable or not, as the Chinese government have introduced new resettlement planning over there. So you have to check the status of whether this is in wrong vein or in positive way they are moving. Next slide, please. So the broad objectives is basically to quantitatively evaluating these future land use land cover changes in this area, quantitatively evaluating the land use land cover in different time domains such as 2018 to 2025. We have split the different time domain 25 to 30, 30 to 40, and then 18 to 2040 as an overall assessment of the earthquake affected area. So identifying evaluating these future the landscape risk area, projected landscape risk area, considering important multiple environmental parameters. So in the last lectures, that we considered, there's the 6 important parameters that is common for this landscape risk analysis. We can consider that we have measure important parameter we have considered, but you have to consider when you have a futuristic approach, you can consider the future land use land cover model, land use land cover you can consider, but you cannot consider the lineament density of the future, because the lineament density doesn't you cannot create. So you have to consider the last one as your modeling even. So because your land use land cover have tells you the progress, how these area have changed over the courses of time. So land use land cover have progressed with the changing nature of the landscape also. The lineament density also gradually changes. So we can easily estimate it, this kind of phenomena, how it is going on in the near future. So study area is basically is a UNESCO World Heritage Site. So it was suffered deadly in 2008 and underwent a massive renovation activities done by the Chinese government with a great initiative 2013. But we identified the problematic, still the problems were there. Next slide, please. So these are the area you can see the Chinese area, the Sichuan province, the Dujianggang city we considered. You can see the water tower was there, the large water area that is diverted in this area, and the Dujianggang city is located over here. These are important locations that we have demarcated with the multiple fault lines crossings over there. You can see why these area have risks during this time, and multiple faults when it's crossing over the specific area. You can easily understand that the risk factor of developing over there. So these techniques can be helpful to assess this kind of change that is going on over there. Next slide, please. According to the Google Earth, the elevation was is in 668 to 1008 slope and average slope are 67.9% and to 18.9% respectively. And the Landsat data of the Landsat 5TM and WLI of the earlier and the recent are considered for the futuristic simulation modeling. Next slide, please. You can see there's the multiple earthquakes, how it impacted in these different kinds of fault region. That from the starting from the like 4.3, 4.9, 5.1, 4.7, 4.2, multiple earthquakes. But when it is the aftershocks and multiple earthquakes or even occurred along the fault lines, so you can easily occur that how this area have changes and stress have been assessed through this kind of lineament changes, and the lineament density can tells you the different kinds of phenomena. So this area is a very complex area. You can see the multiple faults and the multiple earthquakes are occurred frequently. So we have a combination of the geological maps, fault lines, epicenter points, future land use land cover of 2018, 2025, 2030, 40 are, and the linear density map of the 2018 are considered for the future landscape risk assessment. Next slide, please. This is the methodology. As the time is very limited, quickly overview. I've already discussed the different types of data sets are used. So different model validation of approaches and accuracy assessment was performed with the land use land cover data, because you are using the land use land cover. So you have to validate the land use land cover with the either Google Earth or the field validation techniques. So you can validate your data, land use land cover, so that the reviewer may not be ask you questions regarding the validation. But the techniques that is introduced in the Bhopal paper, in the first research that we have already discussed, the linear density and the landscape risk assessment can be further modeling validation approach you can adopt in the next near time, because it's a novel technique that we have already introduced in this Bhopal paper. So these are the two way we can validate the data of the land use land cover as well as the ASP mapping techniques. The Markov model was found suitable for the land use land cover future modeling approach, and different degrees of dynamic land use land cover changes are estimated according to the different time domain. Linear density map was adopted for this with the NV, PCA Geomatica, Rockwork software, and the multiple software integration techniques are adopted in this study. Weighted scores are assigned based on the risk factor close to the fault lines and the other geophysical parameters. Based on this, we have to reclassify and assign the higher and lower risk factor over the specific time domain. So thematic classification map was finally produced based on the natural breaks Jenks classification method. Next slide, please. So future dynamic degree estimation of calculated based on the degree dynamic estimation with the formula adopted. This it can be used for the dynamic gain and loss estimation. Transition matrix are produced with this land use land cover. Next slide, please. Next slide, please. Based on the 2018 simulated data, the results for the different time periods in different time domain have clearly prepared in this study with the help of integrated software. The linear map satellite data was prepared using PCI image. PC1, the first band images are considered for the better data extraction possible with the help of line algorithm with the modified data, and weighted maps are assigned, and then different kinds of land use maps as well as with the geological data, different derived aspects, the slope aspects, and the dam are considered as the integrated mapping analysis. Next slide, please. Next slide. Yes, yes. These are the factor. Multiple buffer are created for the specific layer of interest within the based of the weight is given 5, 4, 3, 2, 1 for the important parameter assigned for specific layers for the important places that we have already marked in the dam. Past earthquake epicenter points have located also. The LD data, land use land cover data sets are considered for this evaluation. So higher risk values are considered and lower risks also assigned based on the buffer. So when the similar to the score, we have to assign that was adopted by our earlier research. So we have considered this for the higher the risk value when the buffer distance is lower, I mean very close to the epicenter. So the lower the risks and the buffer distance is more higher. So the following classes were adopted for the different land use land cover classes was like you can see 1, 2, 3, 4, and 5 for the different land use category. In this aspect, future land use land cover was also produced this order was finally adopted and followed by the future land use land cover mapping, and matrix table was generated in this regard. So if future landscape risk is very high risk and is close to the earthquake epicenter. On the other hand, medium risk represents close to the high risk area. Similar to when the value is very low, it it indicates the low risk to very low risk, and the risk is low because the area is far away from the past epicenter and the geological fault lines. Next slide, please. Next slide, please. Next slide.
This is reclassifications was performed for all layers. Is this the slide that you want?
Yes, yes, yes. This one, yeah.
Okay. In
The
fact, it takes
reclassification was,
time. Huh.
in fact, is good. Yeah.
Yeah.
Reclassification was performed in this field calculator. So geoprocessing wizard was basically applied in the union operator with the ArcGIS software to calculate this kind of future risk map. So this integration was done within this formula. The different weightage was assigned based on the risk factor. So calculated with the risks, with the geology risks, fault line, earthquake points, and other considered for the different risk map we generated. Next slide, please. For the result validation, we have to compare this data of the simulation was performed, the simulated and actual data of the 2018 data we have simulated, and we have performed the value of this particular model accuracy. So found this 0.73, which was quite satisfactory, gives the results. And next. Future land use land cover dynamics and the loss estimation was also performed based on these data sets. So mu it is representing as the built up area, which shows a negative DD with the minus 1.1% per year decrease in the time period during the earthquake and afterwards. And gradually it have representing the different scenario in the next different time periods, indicating the areas of built up area will be at risk for future earthquakes also. Next slide, please. These are the dynamic assessment results of the total area coverage of the different land use land cover. You can see how it changes through the courses of time during the different time domain, negatively is moving the built up area, and and also the reconstructed area. The RA is the reconstructed area. So how is this negatively have impacted in the near future also in different time, in the upcoming time 2030, 2040 also shows this kind of changes. And BL is the barren land. So you can see that the projected of the land use land cover model also projected the different kinds of scenario, how it is the area have changed through the courses of time. Next slide, please. Next slide, please.
This maps slide I had already changed then only. I think it is heavy file. Or this particular slide is heavy, I think. Is that it has come or not for you?
Yes, it is come right
Okay.
now. It's okay, and I will quickly overview the changes as the time is limited. I will quickly see these changes. You can easily observe how the area have changed in the different courses of time. So future land use land cover, you can see the changes of the specific area along the fault lines and other area. The built up area was representing with the increasing heavily with this area and have a higher kinds of land use land use cover change. You can easily observe the maroon color marked as the built up area. Water body is marked as the blue color. So these have undergoing the different kinds of changes that we have noticed in different time domain. Next slide, please. Next slide, please, madam.
This text slide I changed then only. Could you see that? The
Not
change
yet.
the change rate decreases. The text slide. It does not come.
No, it has not come, right?
Oh, I changed then only.
It was earlier slide is still there.
Okay, it is taking time then. I changed then only. It'll come, I think. This is only text slide.
Mm.
Any of the participants can see the text slide, please?
This is we are almost in the close.
Yes,
Yes.
please.
Right now is okay.
Okay,
Yes,
okay.
yes. So the change rate decrease as the minus 0.59% per year, and the negative trend of development was also present over there. Gradually, it have follows the different land use land cover. And the first phase was observed also the minus 1.67% per year, the rate of changes for the period 2018 to 2025. And the future land use land cover will also occur in the reconstructed area. Uh, the Chinese government have reconstructed again after the renovated work. So with the higher negative DD changes, minus 12.69% per year changes in that particular time frame. In the next two time periods, the 2025 to 2030 and 30 to 40, positive changes in DD was also observed, minus 4.7 and 0.53% per year respectively. Over the year, as a overall 2018 to 40, this trend will negatively impact the reconstructed area and the DD leading to changes of minus 3.88% per year uh, with the R square value of 0.922. Next slide, please. These are the different types of percentage distribution of future land use land cover of the DCEN area of the South China from the 2018 to 2040 of the different land use category, how we have changed. So for the trend analysis, land use land cover have prepared based on the projected data by applying second order polynomial regression curve with the regression equation, and the R square value was plotted over there. So you can easily understand the change progress of the different land use land cover category. Next slide, please. These are the special difference maps of the change difference maps. So why it is necessary? Because you have to understand the time as the time progress. You have to understand where the risks was there, where the changes of the land use land cover have happened, and or where it will be occur in the near future. How it is be going on through the modeling approach. You can easily assess. So we can easily identify the change difference of the different time domain. Next slide, please. Next slide, please, madam. You can quickly move on the next one
Okay,
or two
okay.
slides.
This gain and loss I had changed then
Yes,
only. I think few slides take some time.
yes, yes, yes. Because multiple images are there, so that's
I hope
the
you can
slide was
see
more heavy right now.
it. This is table 3. Can you see that?
Yes, table 3, table 4 is there.
Okay, okay. You want to see table 4? This one?
Yes, you can skip. You can skip. This is the result of the change difference maps.
Okay,
So you can easily see the gain and loss estimation over there,
okay.
and we can easily plot it with this data. The changing data
This,
overall I have already discussed. So these are the final outputs of the future projected landscape risk area of the DCN area, the Chinese earthquake affected area, where the 2025 was representing that the top left, and the right part of represent 2030, and the below image representing the future land use land cover of 2040. So you can easily see the overview of the changing nature of the surface of the how the modeling approach of the land use land cover can can give you the idea about the future projected area of the landscape. uh, Next slide, please. These are the outcomes of the mapping approaches that we adopted. The total risk weight class was assigned in and in different number of classes. The risk category we have identified very low, medium, high, and very high category. So these are the risk area percentages. You can see the very high and high risk category, medium category are also increasing in this area. And we have also demarcated according to the different zone. We have segmented the area in different zone 1 to 1 2 3 4. In that way we have to classify it, and which land use particularly have affected, and under which category of risks that developing through this modeling approach, and which important places are considered. So we have also marked this location that is under risk that we have identified. So specifically we are narrow down our risk analysis in this area. So these data have shows you clearly the geological area that have affected by this very low category, low or medium or high stress category. So landscape risk, which category of what type of lands land use are under stress, that you can easily identify. So through these courses of time and the different time domain, the A representing 2025, 2030 is the middle one, and the last one is the 2020 2040. So the risk area you can easily identify that this in recent time or the in future 2025 to 2040, the risk is always of changing status in this area because of the future projecting of the land use land cover in this area. So identifying according to the zone wise is important to analyze the area more closely. Also to
so
identify
over.
the important locations, which area is under the important area, under the high risk or low risk or medium category risk. Next
Here
slide, please.
only can I ask this question, because this
Yes, madam. Thank you.
2531
Please
is
proceed on.
projected very high risk, and risk area is also like increasing, and it that too in zone 2 1 and 1 along with 4. So projections show that
Mm,
risks are increasing.
yes, definitely, because we have a model, because your land use land cover, when it changes through the courses of time, it automatically impacted in the future projection of the landscape risk modeling. Because if you don't have any satellite data, you can only model it, but you cannot project at the landscape risk. Uh, you cannot use the lineament density data as the time progresses. You can consider, but uh, that's why we're developing these modeling techniques for the identification of the landscape risk of the futuristic approach by considering the land use land cover model.
You must be having some methodology for quantifying the damages.
Definitely, you can. There is the low damages. I mean, the risk category. We are not going through the different kinds of settlement damage or other things, but you can approach as the model suggests that this model can be appropriate for the different kinds of risk analysis. So you can easily adopt it according to the settlement wise also to identify the risk area. Also, the damage assessment can be performed according to the multiple time domain.
Okay. Okay.
Next slide, please. We are going to very close to the end of this lecture. The next slide, please.
I changed it. I hope you can see now.
Not here, not yet.
Concluding remarks slide.
Now we have next slide.
Concluding remarks slide
Yes,
you can see.
yes. In this study, finally, we have to summarize that whole analysis. So the land use land cover modeling and the land use land cover areas, probable priority based risk assessment of the environmental sustainability. We have to check for this earthquake affected area and how it will be is under the high risk, in moderate or lower, which categorical are under this area or in the near future. So we have to analyze through the different time interval. A priority based sustainable solution would be further recommended, as well as checking the unsustainable land use land cover movements in the study area. So by observing this kind of futuristic landscape risk pattern, it is high time to properly inspect and discuss the locals to what to do and what their concerns regarding the future landscape change and future landscape risks, which will be incorporated in the future planning of this area to make the DCE and area sustainable. Moreover, the remote sensing GIS integrated techniques help to build a model validated and found to be ideal for plausible future land use land cover prediction, which may also further helpful for the identification of the future probable risk at spatiotemporal scale. And we found these multi-temporal Landsat images of 2007 and 18 are very useful for the generating simulation modeling of the land use land cover, which is very effective to have identified the future land use land cover for the years 2025, 30, and 40 for the respective earthquake affected area. Based on the integrated layers, these including the different kinds of future model, the land use, the linear density, which will change with the time. So you can easily consider the new Landsat satellite data as the Landsat 8, 9. So we can easily consider the more new data in this modeling approach, ASP approach. You can consider with the future land use land cover model. So that will generate automatically the future land use land cover maps. So with the weighted sum method can apply it, and in a consecutive manner, you can generate the future modeling risk modeling based on the data sets. And some more slides of the earthquake affected area. The photos are for the read for you all. You can see the devastating of the particular 2008 8 magnitude earthquake that affected in this area. You will easily understand what is happened at that time. So we have to consider this approach for the future risk assessment to save lives, valuable lives in this area, lives and properties. We have to take care of that. For that, this special analysis is basically suggested for the Chinese government for this, especially to see the planning was in wrong vein in during what they did after the immediate after the earthquakes for the resettlement, restructuring, and urban renewal approach they are doing in this earthquake affected area again and again. There is some photos are attached in these slides. You can please show to the audience.
I changed the slide. Important uh, guidelines to the future. Can you see that?
No, not yet, madam.
Just it's coming. It must be on way to Beijing. You're right now in Beijing, right?
Yes, I am right now in Beijing, returned from lab, and now I am at home right now.
Okay, okay. So it take sometimes some slides it takes time to reach
Time, yes, yes.
Beijing. Yeah, from
Uh,
Bhopal.
basically is already I discussed and important guidelines that is suggested over the year. So the present study, basically the integrated techniques have ability to know the this kind of risk assessment have been performed well, and basically helpful for the identification of the probable pattern of change in the belt and road corridor area, any area you can adopt, which is very much affected by the floods, affected by the landslides, affected by the the earthquakes. So these kind of data sets can be very effective for this kind of futuristic modeling approach, future risk assessment in advance. You can, if you analyze this kind of data with the time, as the time progresses, we have a data, multi-temporal data with the different satellite sensors. So the more the high resolution data of the, suppose for Landsat data in 30-meter of the Sentinel data, so you can easily consider in the IRS satellite data, that all you can consider for your specific region of interest. So these are the modeling approach that you can adopt in any specific micro watersheds level. Also you can test, also to check the status of the risks that developing in your locality. So if it have an earthquake prone area, you can easily identify the where the risk is going on, where the risk factor is developed, and in the upcoming time also. So you can easily aware the people or the local government to say that the area is vulnerable for the future earthquake events. So these are most helpful, find most helpful, and these paper basically are linked with the sustainable development goals, with the goal number 11, to save the cities more safe, resilient, and sustainable. So you can see the devastating of that particular event. I collected it from the literature and the internet during my PhD time. I have used this in the research paper. So you can see the 7.9 magnitude are reported by Chinese government, but Chinese earthquake administration, but UGS have reported it as 8 magnitude earthquake. So you can see the devastating how it happened. The 90 over the 95,000 people are dead along the fault lines. All the buildings are ruptures and it damaged, and people are all dead. They have no time to have a shift in the nearby places or the safer area, the higher grounds. They have no time. God hasn't God given not given enough time to have a to shift to the safer places for their lives. So you can see the time. So that was already marked as a stone mark, as a memorable event. That was deadly earthquakes that the history that is in the people that living in their area, they have their in their mind. Next few photos are there. Also you can see the damage was there. It was very pathetic how the peoples are working, the childrens are in their school during that earthquake time. All are collapsed and dead during this earthquake time. I feel very great. I feel sorry too during that time when I was working on this particular event, but to monitor. Basically, it was a recommended my supervisor after my graduation. I had a 2 months time to stay over there after graduation, before came in my country. So I did this research very quickly, and it was certainly a very good number of impact in the research area across the world. The people are using my research, and the citation is till date is 151.
That's
So
great
that's
news.
the end
And
of my entire presentation of the first and second first and second area that is in China, and the first one is Bangladesh part. So basically, we are focusing on the analytical hierarchy process, land use land cover model, and the landscape risk. How we assess based on the Landsat satellite data. How this is effective for the early assess of the landscape area, which is undergoing risk, or how this area have changes through the courses of time before any sort of disaster event that occurred in particular area of interest. So this was the projects that was supported by our research, National Key Research and Development Program of China and the National Science Foundation of China. Both are supported by our research and funded for our open access program. And these are the publications that is published in the ISPRS, International Journal of Geoinformation of MDPI, which is currently impact factor of 2.8, index in SCI, SCOPUS, EBSCO, and so on. So if you have any questions regarding my research presentation, please going on. I'll happy to have answer your reply.
so, thank you for a very informative presentation. I hope you can listen. I hope my voice is clear for you.
Yes, madam. Yes.
Yes, we all thank you for such great presentation and huge amount of work that you have done. And this will surely inspire the research scholars, mainly who have already joined the this particular FDP. And I would be the first person to ask you one question.
Sure, madam.
If I can remember, this happened in May 2008.
Yes.
Yes, May
Yes.
2008. And then in October 2008, somewhere this was scheduled, the Beijing Olympic, China
Yes, that
Olympics.
that you were right. Basically, at that time, the China was very much, affecting this kind of high magnitude earthquakes, and dealing with this kind of two events simultaneously. And these earthquakes have greatly impacted their economy also, as they are progressing at that time. They are progressed with this Beijing event, Olympic event, the great event. But else also, the within this short time, they have also have some great number of planning, restructuring of the particular earthquake affected area. So engaging lots of people over there to have a restructuring the area. You can imagine that how this area have entirely damaged by this high magnitude earthquakes when the fault lines was ruptured in this in particular area. So the people hadn't of any time to have to rescue them during this time. And the Chinese government also have a very the problems of they faced a big problem in their economy due to this kind of earthquake events, and it took almost 5 to 6 years to recover. I mean, after the Beijing Olympic was over, 2013 to 14, they are recovering their economy. So that is the time you understand that how a great earthquake can have damaged the entire economy, or how they have how they set back due to this kind of earthquakes.
In fact, I think in July, China earthquake was there. And in October, I had visited the 14th World Earthquake Engineering Conference in Beijing.
Yes, ma'am. Okay.
And this
So
is
nice to
really
hear.
yes, unimaginable that how China government could do all this, because
Yes, yes.
during that time they had shifted their polluting industries, and they had done a lot. And I remember in the conference of more than 5,000 people from all over the world, we could not see a thing which was mismanaged. It was so managed. Even we visited the China Wall and the water cube, the bird's nest, the village
Yes.
where you are sitting right now, I think, or
Yeah.
the office where
Yes,
your
yes.
office is there. Many
Yes,
places.
my office is in Olympic campus, and it is located. There is multiple institute are there. As the Beijing Olympic was over, they basically have restructuring all the academic institutions over this particular area where the athletes or the foreigners are stayed over there. So the this kind of buildings and apartments are used for these different academic purposes. They are distributing to the different academic institute. uh, Suppose, for example, they are allocated for developmental biology. They are allocated for the Institute of Microbiology. They are allocated for my institute, like Aerospace Information Institute. Earlier, it was in Institute of Remote Sensing and Digital Art, the RADI. So it have merged when in the year of 2018, end of 18, they have merged a bigger institute of three institute merged together under the head of Chinese Academy of Sciences. So more number of academic institutions are within these Olympic villages.
I request participants to please raise their hand if they have any question. We have all the time in the world for them.
It would be good if anyone have any questions, then I can give you the specific answers to have supporting for their research in future.
Yes, please raise your hand, or straight away you can unmute yourself and ask a question. So, sir, yes, Abhinam Bharadwaj, please ask your question.
Hello, am I
Yes,
audible?
Hello.
yes.
Hello, good evening, sir.
Yes. Thank you for.
Sir, sir,
Please
I want to ask.
ask your question.
You have shown the LULC changes classification. I want to ask that how to extract the data for this LULC change extraction.
I mean the data that you have considered, the land use land cover, that you have the uh, supervised classification techniques, the maximum likelihood approach was adopted, and then for future modeling, we have considered for the I mean the LCM, the land change modeler LCM. Idrisi LCM modeling software that was considered for modeling purposes. But before that, we have considered the two images like 2018 and earlier the data. The 2002 data sets are considered for the simulation. So when you have a simulation data, then you consider for the future projection. That is that you can perform in this LCM software. So you can rightly put the specific area of interest, like the which year you are considering for your future projection. So if it 5 years interval, if it 10 years interval, you can put over there. So the data of the future land use land cover will be generated based on these simulation data of the land use land cover, which you have considered earlier and the recent data.
Okay, so but I was just asking that we need some pre-processing for the satellite data, or directly do the supervised classification on the that
Guys,
bands from USGS?
my okay, okay, I understand your point, but what I request you, if if you consider the earlier data, I mean the USGS of recent time have uses the level 2 data sets, so that is not available in the earlier time. So when I was in research, the progressing with the research, so the data was in very raw stage, so we have to pre-process with the radiometric correction, atmospheric correction. So we have to got the surface reflectance data products, and then you have to utilize for the land use land cover classification. Without pre-processing, you cannot consider the data directly, or you cannot extract information. So that will gives you basically the, if you're not correcting the data, corrected data, if you do not have any atmospheric corrected data, so that all the data will be scientifically not be approved. I mean the different, if you directly apply the raw data on the raw data, it will not be accepted in the scientifically.
Okay,
So
okay,
you have
sir.
to process the data always before extracting any sort of information, whether it land use land cover, whether it NDVI, whether it water index, whatever. But if you have a process data, but that is recently available, that is uploaded by the USGS, so you do not need to process the data. Just directly you can use I mean the L2 data set, L2 data of the Landsat data. So so you can directly
Sir, I
use it
think
for your
after
specific purposes.
2013 we have level 2
Level 2 data
data.
is okay.
Yeah.
Yes, level 2 data you do not need to pre-process.
Okay. Oh, so that pre-processing will be done on GIS only, or on the that USGS site?
No, no, that basically they are uploaded by processing, pre-processing, correction, atmospheric correction done by the USGS team. So they are freely available to us for our research. So basically, it reduces our user
Okay.
level time. It
So
so
it is
that you can
available on
directly use this
USGS
the
site
Landsat
only.
data. Yes, yes.
Okay, 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 okay.
But mind it, the other satellite data. Suppose the Sentinel,
Mm.
you have to pre-process the data before extracting any information.
Okay, okay.
So the atmospheric correction of the other data sets is always demand, and it must be corrected before have a required data or indexing you can perform over the specific satellite images. So in this track, I will tell everyone that that's how this single satellite data have effective for the different types of analysis. Suppose you have an interest on the land use land cover, you have interest on landscape risk, you have interest on water index calculation, you have interest on soil vegetation analysis. So many things you can perform, but you have to always have to correct the data first. If your data doesn't provide you the atmospheric corrected information that is representing the surface reflectance product.
Okay, okay. Thank you, sir.
Thank you.
Thank you, Abhinam Bharadwaj. You can just tell us your affiliation, from which institute or industry you
Uh,
are.
Ma'am, I'm a research scholar at NIT Hamirpur, Himachal Pradesh.
Okay, okay. Thank you so much.
Yes, ma'am.
Anyone is
Okay,
having
thank
any
you.
question after Abhinam? I hope there is a lot to understand, and the methodology itself is so unique and so different. Um, in fact, this you have done in China, right? For
Madam,
China earthquake, for
I
Bangladesh
want to add
earthquake.
something.
Yes.
Uh,
Y-
Based on this land use land cover future projection, one Chinese student from at that time, he she was she and another is the male person. Uh, two students, Chinese scholars, contacted me when I was in Bangladesh. So during that time, one is from China, one is from Baghdad, Iraq. So they are basically interested to work on the Baghdad war zone to have assess this kind of analysis. So we have also implemented this kind of area where the earthquakes and the multiple problems was in Baghdad area have assessed also. That paper also available in my Google Scholar. So readers are also uh, if they are interested, they can also visit my Google Scholar profile to see that kind of uh, research that we have published in the remote
I
sensing and
just
DPI journals.
yes, yes. Anybody can Google your name and can get the open access publications from Google Scholar, from SCI, from Scopus, EBSCO, or any indexing. I wanted to ask one
Yes, that is
thing. Yeah, that in India we have this.
available freely.
Yeah, yeah. Okay, okay. Thank you so much. In India, we have this seismic zonation codes, right? So on that basis,
Yes, yes.
we do the quantification and we do the categorization on the basis of vulnerability atlas of India, or we adopt some kind of a methodology. So I just wanted to ask, uh, some other time if we organize some event or this type of a thing, we would be really interested in what kind of map or codes and policies and bylaws Bangladesh has, China has, because here in India we have what set of laws, bylaws, and the principle and concepts are the same, I think, because you have to have for architects and planners, you have to have the symmetrical or the bands, then material wise the bands and the structure changes, but then the map, the vulnerability, like zone, we have zone 2, zone 3, zone 4, right, and then 5, one is not there, and then we have intensities depending on MMS scale and MSK scale. These are most popular. So in the methodology, definitely next time we would like to know all these things, because now I think the time is almost going to be 9:30 and our program is scheduled till 9 o'clock. So any small comment on this?
Madam, I want to share one thing in a very quick second. Uh, Hello.
Yes, sir. Yes, you are audible.
Yes, basically, this kind of analysis is very suitable for the because the algorithm that I uses for the lineament feature extraction from the Landsat satellite data, that is also applicable for the Sentinel. That is also applicable for the other satellite sensors, and that is basically modified by my own think tank. So that is widely accepted for the micro level analysis. So that is very suitable for the micro level analysis of the risk factor, basically applied for the micro level earthquake risk assessment.
Yes, what we called here the microzonation
Yes,
type of a
definitely.
study.
You can
Yes,
move on. Yes.
yes, yes. So thank you very much. And if Pawan sir is there,
I very much see that he is still waiting
is he
over
still
there.
waiting? Is he still waiting? If he is still waiting, then one person had a question for him. Uh, I don't know
I
if
don't
he's.
know whether he is present or not right now.
No, he's not there. Otherwise, one question
Oh,
was
okay.
there, small question in the
Okay.
group. But
Okay, no
then,
problem. Just you can, if you have any further question, I can reply,
no,
or
no,
you can
no.
communicate.
Questions. Anybody is
Sure.
having any question, please? One last question. I think now everybody is very like they have seen your work, and now they need to digest. We need to digest your work. Very nice work, and we wish you
It
all
was
the success
it was a
and
very
more.
good to participate
Yes,
in this this program that you organize, and I am very much happy to present my research work in the worldwide researchers that you have in within your community. If they will be benefited, I will be very much happy to see their works. Or if anyone needs some help regarding this kind of analysis, I am ready to introduce my core value, that the value, that is how we extract the data, that the processing and the other steps that I can share with them if they need some assistance.
please send an email to a professor, and he will reply with your to your query, and you can always google his name and you'll find his publications and his methodologies in detail. So finally the time comes to say goodbye, and to finish and conclude this session. And we all thank you so much, Biswajit sir, for taking so much interest. And you are participating and giving us expert session from that Beijing, and you belong to Bangladesh. And thank you very much. Thank you so much.
Thank you so much, madam. Thank you so much
Yes, all.
for inviting me on this
Yes, sir.
presentation.
Once again, if those people who are not present in the middle of the session, they can switch on their cameras and we can say goodbye after that. Thank you, participants, for a very patient listening. We have wide specialization in the participation. That is amazing. Yes, sir. Thank you so much, sir. So now, what must be the time in there, Beijing?
Uh, Madam, it is 12 3 a.m. right now.
Oh my God. Okay, so thank you
No
so
matter
much.
no matter, I have a work after that. I
Yes.
will I will also work for IGRAS 2025. I will prepare papers and it will be submitted tomorrow.
Oh my God. So
You
without wasting a moment, we wish you success, and may your all papers accepted. And please bless our research scholars and
Thank you,
just
madam. I
everybody.
always blessed with the scholar that is doing their PhD. If anyone, because in currently I am supporting one master's student and one PhD student virtually for the IIST Shibpur, Howrah, in West Bengal, India, to support his research with the remote sensing and GIS. Because though he is in earth science and geological background, uh, but my interest is also in this discipline, so I interact with this activity. We had a good number of research paper published with this one professor from IIST. So I had a good team with that formed in 2011. So it's continue. We are doing some research, collaborative research.
So definitely our research scholars from India will be contacting you soon. Thank you so much. Thank you. We'll be
Thank you, madam.
collaborating on
Thank you, madam.
next work.
Thank you, madam.
And
You are
I
welcome. You all are welcome to visit my country. When I will be in my country, you can please come, and I'll be very much happy to receive you all in a
yes, we
conference or
we
in
may
anywhere.
yes.
If you interest to visit you can come because my university is located in a very hilly area. It's a beautiful place uh, in the Chittagong hilly area.
Definitely in Bangladesh, we want to come. We also want to come to Beijing, and
Sure, madam. Sure.
definitely they have different
I have visited your
vulnerabilities.
university.
Oh,
Sure, sir. Sure, sir.
I
You can
had been
come,
to
and
Chittagong. Yeah.
I will stay. I will stay in
No, no, I
Beijing.
had been to your institute. Yeah.
Oh,
I came to architecture department there. Kanu Kumar Das was there at that time.
okay,
I think you must be
sir.
knowing him. Yeah.
Yes, yes, sir. And very, very happy to know your, the status and the things that you have shared with me.
Yeah, yeah, yeah.
And I spent a lot of time, my valuable
Anyway,
time
nice
in India,
hearing you.
in Kolkata. I stayed over there in Jadavpur University,
Mm-hmm.
as well as I participated in different
Mm-hmm.
conferences
Mm-hmm.
in Hyderabad, NRSC, Ahmedabad. I
Okay.
visited
Mm-hmm.
in Gujarat area also, uh, Rajasthan. These are the typical area that I have visited during conferences, and different
Yeah,
conferences I
yeah.
participated. And each year I went in India for my eye
Is a
checkup
very
basically. But for my doctor was in India.
okay.
Is located in Kolkata,
Yeah.
so I have to visit it
Mm-hmm.
in each year. But uh, due to my research engagement with the Chinese, then I was not in India for the last couple of 2 years. I mean, maybe near about 2 years. I hope I will have to move when the situation is normal.
Okay. Yeah. Yeah, I understand. Anyway, nice meeting you. Have a good
Yeah,
time.
have a
Thank
good time,
you.
sir. Thank you,
Thank
sir.
you for your
Thank you, sir.
presentation.
Namaskar.
Okay.
Namaskar, sir.
Namaskar.
I have, I think, some message from Pawan sir. Hey, he left at 9 o'clock.
Oh,
He says
thank
I
you.
will send a detailed reply, and then I will share it on the group. No worries.
Okay.
Okay. Thank you so much, sir. Good
Thank you.
night.
Thank you, madam. Thank you, madam.
Good
Thank you.
night.
Goodbye. Goodbye.
Yes. Goodbye.
Have a good time, sir.
Yes.
मौसम तरीके से
Sometimes we will also invite you to our institute.
Hello, madam. Hello.
No, no, I said that sometimes we may also invite you to our institute.
Yes, yes, no problem. After my return, you can invite me so that I can move on with the visa procedures and the things. So
Yes, yes,
just
yes, yes,
no problem, no problem.
yes. Or maybe, okay. So until everybody is leaving, I have to leave. I'm the last person to leave
Okay,
in the
okay,
meeting.
okay, madam, no problem.
Yes,
I will inform you as we have connected with the WhatsApp. So no problem to send you the update message after return,
yes, yes,
so that you can organize it they or let me know about the timing so that I can arrange the visas and other things as per the
yes,
suitable
yes,
time.
yes, yes.
So
Or
it would be good.
otherwise,
Yeah,
online event if we have, we will definitely invite you. Now
sure,
that
madam,
we
sure,
know that.
Sure.
Okay, thank you
No
so
problem.
much.
No,
Thank
thank you,
you.
madam. Thank you. Have
Almost
a nice
all
time.
have. Yes, have a nice. Good night.
Good night, madam.
Yes.
Good night, ma'am. Good night, sir.
Good night. Good night, Manmeet. He's my research scholar from PhD.
Oh,
The
very great.
last
Good to
one,
know.
yeah.
Good to know.
Yes, yes, he
There's
works
so
a
many
lot.
scholars are participating in this
Yes,
program.
yes, 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 yes. Okay, good night, sir.
Okay. Thank you,
Good
madam.
night. Okay.